All right, let's take a look at number one. Number one is about a water rocket and the fact that the height above the ground in feet of this rocket after t seconds of being launched is modeled by this function right here named s of t. So part A says, what is the maximum height that the rocket can reach? All right, so a couple things we want to think about here. So if you're on your A game, the first thing you might notice is that this function has been given to you in vertex form. And anytime your function is in vertex form, the vertex itself can be identified by that horizontal shift value on the inside, also known as h in the skeleton of this formula, as well as the vertical shift as identified by parameter k in this function. And so if you think about vertex form, this function is trying to tell you that the vertex went to the right 2 units and also up 66 units. So to the right 2 and up 66 would tell us that the vertex of this function is at 2 comma 66. Now we can also certainly fact check this by plugging the function into Desmos. So if you go just into your Desmos and say y equals -16, quantity x minus 2 squared plus 66, adjust your window, you will see, okay, here we go, adjust. There we go, we're getting there. Okay. You can touch it and see for yourself that the vertex is indeed at 2 comma 66. And yes, it is a maximum since the parabola is upside down. So however you want to go about it, but the maximum height, notice height, that'd be the output value as indicated by the y value of your vertex, in this case would be 66 feet. Part B, how long is the rocket in the air when it reaches that height? Well, again, the input variable in this function is variable t for time in seconds. And so the input quantity of your vertex tells you the time associated. So it's going to be at 2 seconds. So for part C, determine the vertical intercept and explain its meaning. Okay, so for vertical intercept, let's just talk about options here. So option number one on Desmos, vertical intercepts are always touchable points of interest. And so if you go into Desmos and just literally touch the vertical intercept, you will see that it's at 0, comma 2. You could also certainly always, I don't care what chapter we're in, always, you can just plug in a value of 0 for the input and compute that. And if you type all of that expression into Desmos, you will also simply confirm the fact that the vertical intercept occurs at 2. So no matter how you slice it, the vertical intercept is going to be at 0, comma 2. Now, what does this mean contextually? So again, keep in mind, in this context, the input is the unit of time, and the output is variable s, but what it stands for is the height. And so contextually, what this vertex is telling us is that the rocket is launched. I knew to say launched because it's essentially at time 0, so it hasn't been, off the ground yet. No time has passed since it's been launched. So that means it's actually been launched from an initial height of 2 feet. Okay, time 0, 2 feet. There we go. Part D, determine the horizontal intercepts and explain their problem context. Okay, so horizontal intercepts, guys, that's definitely going to be Desmos on this one. So if you look at your parabola, it does have technically 2 horizontal intercepts. One of them seems to be at negative 0.03, so negative 0.03, and then the other one is at 4.03, comma 0. So those are the 2 horizontal intercepts. Now, what do they mean contextually? Well, again, they both stand for time and then corresponding height. Variable s, yes, I know, but what it stands for is height. So I'm going to use the letter h just to keep my brain in the right place here. So in terms of what these mean, so this guy would mean at negative 0.03 seconds, I guess the height is at 0. But if we're talking about launching a rocket, why do we care about where it was negative zero point 0.3 seconds ago. Like you've either launched the rocket or you haven't. So on this one, I'm pretty tempted to just say no meaning because of the fact that it has that negative unit of time. And again, what are we talking about if we haven't even launched the rocket yet? Now, 4.03, on the other hand, that also stands for a unit of time, and you can certainly have 4 seconds after it's been launched. And what's happening after 4 seconds is that, well, the height would have been 0. So that definitely has some meaning. So the height is at 0. So essentially, that means it's landed on the ground. So a height of 0 means it's on the ground, 0 feet. And it takes 4.3 seconds for that to happen, 4.03 seconds for that to happen. So no meaning for the negative one, and the positive one just means that after 4.03 seconds, the rocket is indeed on the ground. All right, part E, write the function in factored form. Okay, if you recall, factored form is essentially you've got your A value, which is what it is. That's given to you most of the time in the original, well, not most of the time, it will be given to you in the original function. And then the factored form looks like this, and where these values come from are your two horizontal intercepts. So x1 and x2 are simply your horizontal intercepts, which we have them right here. So if we just use those, so our function is s of t, the a value was given to us in the original problem as negative 16, so it still is negative 16. And now t minus my first x-intercept, which was negative 0.03. So technically it is minus a negative. I'm going to cut that process, make it all in one step here, and just say plus 0.03. And then similarly, t minus the other horizontal intercept, which was 4.03, so minus 4.03. So that would be the function in factored form. Okay, so to convert it to standard form, part F, write the function in standard form. So you are going to want to distribute out essentially either the vertex form, which was given to you in the beginning, or the factored form, which you now have in part E. I'm going to go back and use my original vertex form, not only to just practice it that way, but also, I don't know, like if this was me on a test, just in case I made a mistake in part E, I don't think I'd want to distribute that out just because now I'm going to have what I call snowball effect. If part E is wrong, well, then obviously if you distribute part E, well, now part F is going to be wrong too. Now, the good news is we're going to quote grade with you. We're not going to like double dock you if that's the only error that occurred. But still, for our own sanity, it's always sometimes helpful to go back to something that you trust and know to be correct, like the original problem, and build from that. So that's how we're going to approach this one. Now, when you get ready to distribute this puppy out, the first thing you have to acknowledge is you have a quantity squared. And as far as the order of operations are concerned, that needs to be acknowledged right away. So we have the negative 16, t minus 2 being squared means to times it by itself. So that's the first thing that we're going to acknowledge. Now, after this, you have options. You can either A, distribute the negative 16 into that quantity, or B, you can distribute out the two parentheses first. It doesn't matter. You just kind of have to pick your poison and roll with it. I'm sort of a creature of habit, and I like to distribute my double parentheses first. So that's where I'm going to start. So I'm going to leave my negative 16 alone. And now I'm going to distribute my t minus 2 times t minus 2. So starting with variable t, t gets multiplied to this t, making t squared. And t also gets multiplied by negative 2, making negative 2t. Similarly, the negative 2 also has to get distributed. So negative 2 times t is another negative 2t. And negative 2 times negative 2 makes positive 4. So all of that is what you get when you distribute that out. Now, again, as far as options are concerned, you could now multiply the negative 16 all the way in. Me personally, I like to fully simplify and quote unquote finish what's in parentheses. So I'm going to take a quick second and I'm just going to simplify my like terms in here. So t squared is obviously still t squared. Minus 2t, that makes minus 4t. And of course, the plus 4 on the end. Don't forget your cute little plus 66. Okay, so now the double parentheses are completely and officially done. Now we can distribute the negative 16. So negative 16 times t squared, negative 16 times negative 4, negative 6, oops, negative, hello, backwards, there we go. 16 times negative 4, 64 positive 64 t, and then negative 16 times positive 4 is just negative 64. Don't forget your cute little plus 66 on the end. And then one last step, you do have some like terms right here on the end now. So to finish this problem, we will combine those like terms. So S of t is equal to negative 16t squared plus 64t. And those like terms on the end make a plus 2. Now, as soon as you get that final answer, my hope is that you've got some warm, fuzzy feelings because in standard form, the C value should always be your vertical intercept. So positive 2 should be the VI. And if you recall, oh, yeah, it definitely is. So we just confirmed in our distribution that our vertical intercept is indeed at 0, comma, positive 2. All right, so that's a wrap on question 1. Hopefully you found it helpful. Thank you.